Welcome to the fourth lesson in Chapter 6 of the Pearson Geometry video series. This lesson covers the theorems that allow you to prove that quadrilaterals are parallelograms. Let's go over the theorems, then you can pause video and fill in the balloons. After you have them written down, I will explain them using the diagrams. These are the theorems. Assuming that you're looking at a quadrilateral, Theorem 611 says if the opposite sides are congruent, then you have a parallelogram. Theorem 6.2 says, if the consecutive angles are supplementary, that means they add up to 180 degrees, then you have a parallelogram. Theorem 6.13 says, if the opposite angles in the quadrilateral are congruent, then you have a parallelogram. Theorem 6.14 says, if the diagonals bisect each other, then you have a parallelogram. And Theorem 6.15 says, if one pair of sides is both parallel and congruent, then you have a parallelogram. Okay, go ahead and pause the video and make sure you get all of these balloons filled out. As soon as you get the theorems completed and written down, then start the video again. Okay, let's take a look at the first one, Theorem 611. This one says, if the opposite sides are congruent, so these two sides are congruent and these two sides are congruent, then it's a parallelogram. Theorem 612 says, if A and B add up to 180, B and C add up to 180, C and D add up to 180, that means each of those pairs' consecutive angles, the one right next to the other one, adds up to 180 degrees, then it's a parallelogram. In Theorem 16, if these opposite angles and these opposite angles are congruent, B is congruent to D and A is congruent to C, then it's a parallelogram. Theorem 6.14, if X is the midpoint, that means that BD and AC bisect each other. Then that means that AX and XZ are congruent and BX and XD are congruent because X is the midpoint, then it's a parallelogram. And finally, if one pair of angles is both congruent and parallel at the same time, then it's a parallelogram. Okay, let's take a look at this and see how we're going to use it. In example 1, we want to figure out, given this information, if DEFG is a parallelogram. Okay, so the only thing that we know is that we have these three angles. We do know that in order to find angle D, we can subtract angle E, angle G, and angle F from 360 degrees. That is 360 minus 153 minus 153 minus 27. And if we do that, we're going to get 27, which means that angle D is 27 degrees. Now, using Theorem 613, that says opposite angles are congruent, we have 27 and 27, 153 and 153, so we would have to say yes. This is indeed a parallelogram. All right, now example 2. So this one we know all four angles, and if we look at the opposite angles, 89 and 91, 91 and 89, those are not congruent. Now the theorem before it that says, are they supplementary? Okay, L and M, 89 plus 91 is 180. And O and N, 89 plus 91 is 180. But if we add these two angles, which are also consecutive, 91 and 91 is 182. So we're going to have to say no. This is not a parallelogram. This is actually going to be a trapezoid. Maybe, if we have another set of parallel lines. Okay, example 3. Let's see, if we solve for R and S, we can see if these are going to be the same. Well, if we solve for them, assuming that they're the same, because it says that for what values of R and S making WXYZ a parallelogram, that means that XY has to be congruent to WZ and XW has to be congruent to YZ. So we can say that S plus 5 is equal to 2s minus 2, and we'll subtract s from both sides and add 2 to both sides. S is going to be equal to 7. Okay, now let's work with the t's. So we've got, or r's, I'm sorry. So we've got 4r plus 7 is equal to 7r plus 1. So we will subtract 4r from both sides, and we will subtract 1 from both sides, and we're going to get r is equal to 2. So s is equal to 7, and r is equal to 2. All right, let's flip this over. Okay, in example 4, it asks for what values of a and b is RSTU a parallelogram. Okay, for this to be a parallelogram, we know that opposite angles have to be congruent. So we can go ahead and say that 5a must be equal to 3a plus 14. So we will subtract 3a from both sides. 2a is equal to 14, which means that a is equal to 7. So we know a is equal to 7. Okay, in order to find b, we're going to set these two angles equal to each other. So 4b plus 1 is equal to 3b plus 37. So we're going to subtract 3b from both sides, and we're going to subtract 1 from both sides. So b is going to be equal to 36. All right, example 5. X equals 25 and y equals 30. Is this a parallelogram? Well, let's go ahead and plug these in and see what we've got. So right here, we've got x plus 15, which is 25 plus 15, which is going to be 40. Okay, and we've got 2x minus 10. So 2 times 25, which is 50, minus 10 is going to be 40. Okay, over here, we've got 3y, which is 30, so 3 times 30 is 90, plus 50 is 140. And over here, we got 5 times 30 is 150, minus 10 is 140. Okay, so we've got a couple different theorems we can use here. First of all, opposite angles are congruent. Okay, so definitely a yes. What else could we use here? How about consecutive angles? So 40 plus 140 is 180. 140 plus 40 is 180. 40 plus 140 is 180. And 140 plus 40 is 180. So all the way around, we also have consecutive supplementary angles. So that's another reason that we can say yes. Okay, let's take a look at example 6. So g equals 14 and h equals 5. So if h equals 5, 5 plus 1 is 6, and 2 times 5 is 10 minus 3 is 7. We don't even have to go any farther because those sides aren't congruent, and the sides have to be congruent. Okay, let's see, example 7. I suppose we should go ahead and finish this up. All right, example 7. For what values of P and Q is ABCD a parallelogram? Okay, so if it's a parallelogram, this is a midpoint because these are diagonals are going to bisect each other, which means that these two sides are going to be congruent and these two sides are going to be congruent. So we can say 3q plus 1 is equal to 2q plus 3. So 3q plus 1 equals 2q plus 3. Let's subtract 2q from both sides and subtract 1 from both sides, and we get q is equal to 2. Now let's do the same thing to figure out what the p values must be. So if this is the midpoint, and it would have to be in a parallelogram because these bisect each other, then 7p plus 1 is going to be equal to 5p plus 3. So 7p plus 1 is equal to 5p plus 3. Let's subtract 5p from both sides. Let's subtract 1 from both sides. So p is going to be equal to 1. So we have q is equal to 2 and p is equal to 1. All right, example 8. Is this a parallelogram? Okay, so if this is a parallelogram, then these two sides would be congruent. Okay, so we know that. And opposite angles would be congruent. And these two angles, consecutive angles, should add up to 180 degrees. So let's add those up. 132 plus 48. So we are going to get 180. So therefore, we would have to say that yes, this is a parallelogram. Okay, finally, example 9 is WXYZ a parallelogram. Okay, let's see. We know that this is the midpoint of these two lines right here, but we don't know if these two parts are congruent. In other words, we don't know if this diagonal bisects this one. We don't know anything about the angles. We don't know anything about whether the sides are congruent. So for this one, we would have to say not enough information. It might be, if we knew that these two were congruent, then we would say yes, that would be enough. Okay, now, for the last part of this, this is something that you're going to do on your own. Each one of these lines up with one of these. These are your triangle line segments. They should be familiar. We've gone over them several times. So, next to each one of these, put the letter that describes the triangle line segment that you're looking at right here. Okay, over here, these are your points of concurrency. So figure out which triangle line segments intersect to give you this point of concurrency. And same thing, put the letter of the correct triangle line segment next to its point of concurrency. And we will take a look at these in class. Any questions? Make a note of them, write them down, and we'll take a look at it. Thanks, see ya.